Hey y'all. Okay, so we've got a video today. Just for some context sake, I'm actually in the building. Some of you did know this ahead of time. I didn't get a chance to tell all of you because of the quiz we were taking. This is going to be the beginning of our second section of trig. This is going to be a really important lesson to have our conversation both tomorrow, Wednesday, and then on Friday. So this won't take very long to watch as a general rule, but we just want to make sure that we fully understand. So I'm going to really quickly just remind you of some basics. So things that we've been talking about, the idea of SOHCAHTOA, where we talk about the sine of an angle from a right triangle. If I talk about this as angle A, B, and C, and this side A, side B, and side C, the ratio of the sine of the angle, and let's reference a specific one here, is going to be the ratio of the opposite side over the hypotenuse. And we know that my cosine of, let's just randomly choose, cosine of my angle, and actually in cosine of B, would be A over C as well. In this case, it's the adjacent over the hypotenuse. And finally, the tangent of my angle, we'll go back to angle A here for a minute. The tangent of A is A over B. In this case, it's opposite over adjacent. Now, moving forward, we're going to actually tack on 3 new trig functions. We're going to not only say that side of the angle is opposite over hypotenuse, we're going to tack on its reciprocal function. The cosecant of an angle is its reciprocal, the hypotenuse over the opposite side. So if we were to go up to angle A here and say, hey, what's the cosecant of the angle? We would literally just take the reciprocal of that and say, oh, okay, well, if I take angle A, its hypotenuse is C and its opposite is A. Moving forward, we're not only going to say that the cosine is adjacent over hypotenuse, we're going to tack on its reciprocal, which is secant. And we're going to say the secant of that function is the hypotenuse over the adjacent. So if we were to take the secant of B here, then we would not only say, oh, well, the cosine is A over C, its secant would be C over A. You can imagine where we're headed with this. If I were to talk about not only the tangent of the angle, which would be the opposite over the adjacent, I could tack on its reciprocal, and we're going to call that the cotangent of the angle. The cotangent is, again, its reciprocal, the adjacent over the opposite. And so, in referencing the tangent of A, its tangent is opposite over adjacent, so its reciprocal cotangent would be B over A, which would be adjacent over the opposite. Now, we're going to reference that from now on. We reference it really quickly. So, just make sure that if you need to, go back to this page, and we're going to start to add in what is one of the most important conversations that we're going to tie back to things from here on out. We're going to start talking about the terminal side of an angle. And I'll remind you from last week and the week before that when we have an angle in standard position, we have an initial side on that positive x-axis. This specific terminal side is going to stop at the point 2, 5, or I should say the angle is going to stop there, meaning its terminal side is going to run through that point. And our job is going to become to find the value of 6 trigonometric ratios of the reference angle formed. So to help us with this, we're going to consider that yes, this ray of the angle goes on forever, but no matter where I stop it, if I were to stop it here, or to stop it here, or to stop it way out here, we would have what we consider similar triangles. And in having similar triangles, we know that my angles would be the same, and therefore it would not matter part of which triangle I chose to reference, my sides would be proportional. So I'm going to choose to stop it at that point itself. And I'm going to consider taking the altitude from the point and drop it to the closest x-axis. You're going to hear me say that a lot. We're going to form this right triangle. This is the size of 2 and the size of 5. And so if I want to start to talk about the sine of the angle or the cosine of the angle, the tangent of the angle, the cosecant of the angle, the secant of the angle, or the cotangent of the angle. If I can find this side, then I can reference all 6 of those trig functions. In your gut, you know how to do this, but say it really quickly, hit pause, and see if you can find what we would consider this other side of the triangle. Okay, so as you know, this is the hypotenuse of this right triangle, and the hypotenuse can always be found by the Pythagorean theorem. So by finding that side, I can take the square root of 2 squared plus 5 squared. That's the square root of 29, which does not rationalize, or which does not simplify. The sine of my angle is opposite over hypotenuse. Now, for time's sake, I'm not going to make you rationalize. We'll talk later about when to rationalize and when not to. But for now, go ahead, hit pause, and find these other 6 trig functions. Okay, my cosine would be 2 over root 29 for adjacent over hypotenuse. My tangent would be 5 over 2. And then for these, I literally find my original 3's reciprocals. The cosecant is the reciprocal of sine, which is the square root of 29 over 5. The secant is the reciprocal of cosine, which is square root of 29 over 2. And the cotangent is the reciprocal of tangent, which is 2 over 5. So with that, go ahead and go to the next slide. Now, you're going to notice, this gets kind of interesting, for me at least. We've got a terminal side now that stops, or that goes through the point -2, 5. Now, quickly, you might be like, well, wait a second, isn't that a similar point? Absolutely it is. But watch what happens to my 6 trig functions. I have an initial side here and a terminal side here. So I'm going to ask you to hit pause. I'm going to ask you to hit pause and see what you can find in terms of this triangle. Okay, if you go ahead and drop that altitude, and you're going to hear me say this a lot, we're going to drop the altitude from the point here down to the closest x-axis. There is my right angle. I've got a size of 2 and a size of 5. And this is still the square root of 29. Now, the first thing that you should notice, however, is this is in the second quadrant, making that -2. So then, what happens to my 6 trig functions? Well, if I start to list these, my sine is still 5 over root 29, but now my cosine is -2 over root 29. My tangent is -5/2. My reciprocals, still hopefully feeling decently easy. I flip sine. I flip cosine. And if I can add this on here, and I flip tangent. So one of the things you're going to notice, and I'm going to ask you to follow along with this, with your calculator with me on this, is that we suddenly have these negative values. Now, in your gut, you might be like, okay, well, I kind of get it because I'm in the second quadrant. But I want you to follow this to see, take your calculator, if you would, please, to see how do we deal with this reference angle. This reference angle that's here in that second quadrant. Now, this is going to start to make sense now, not completely probably, but go ahead and take 5 divided by, actually, let's do this. Do -2 in your calculator, divided by root 29. So take -2. So again, get your calculator out if you don't have it. Hit pause if you need to. We're going to take -2 and divide by root 29. and you're going to get the value of negative 0.37. Now watch this, and this might make sense right now, it might not. Don't panic if it doesn't, we'll deal with it more tomorrow. But if I take the inverse of that, I get 111 degrees. This is 111 degrees. So you might be like, well, wait a second, but isn't this the angle that we're finding? That answer is yes. So for a quick minute, do 180 minus 111.8. 180 minus 111.8, and you get 68.2. So my reference angle is 68.2. Now, if you were to take the cosine of 68.2, you would get the positive 0.37. So how does our graph help us? Our graph helps us adapt for these angles that for the first time ever can be bigger than 90 degrees. Now, I don't want to overstate this other than to say that this isn't going to make a whole lot of sense until the end of the week, realistically. But what I want to emphasize is, up until right now, we really never found the sine, cosine, or tangent of an angle bigger than 90 degrees. And now for the first time, we are moving into quadrant 2. And when we do, for the first time ever, we've found the cosine of 111 degrees, which we found is negative 0.37-ish. And in looking at that, we've somehow related it to this reference angle. So what you should be noticing is the reference angle helps us, and it matters what quadrant we're in. So for the last example, we're going to look at quadrant 3. We're going to draw point -2, 5. Notice these are the same numbers. That is totally purposeful. We've got an initial side. We've got a terminal side. And what am I going to do? I'm going to find that reference angle. How? I'm going to draw the altitude of the triangle from this point to the positive or the closest x-axis. I'm going to draw that right angle. This is the size of 2. This is the size of 5. But what's the difference now? We're in the third quadrant. This is still the square root of 29. So hit pause, and if you would for me, crank out those 6 trig functions. The sine of my angle now for the first time is negative. The cosine of my angle is negative 2 over root 29. The tangent of my angle is now positive 5/2. Why? Because it's a negative over a negative. The cosecant of my angle, you get the idea here, still just take those reciprocals. Got the secant, I said cosine, sorry, cosecant. Cosecant of my angle is root 29 over negative 5. Secant of my angle is root 29 over negative 2. The cotangent of my angle, 2/5. You get the idea. What I want you to do for homework is to take that corresponding worksheet that came along with your notes, and if you would for me, please, there are 5 questions, very similar to what we just did, but with different numbers. I want you to follow those directions closely. It is going to ask you to find the reference angle. That may make sense, it may not totally make sense, but this is going to be a huge driving force behind what we're going to do tomorrow. I hope you have a good rest of your day. Thanks for watching.